Hey everyone, I'm Frederick, the micro hobbyist, and welcome to episode 1 of the upgraded 6309 Unleashed series. Today, I'll walk you through the roadmap for this retro homebrew computer, the challenges, detours, all the bells, whistles, and potential migraines you can get from chasing mystery chips online. Buckle up, because this rabbit hole does not have an exit. A tiny rewind I owe you from episode 0. A quick who am I and what are we building refresher. Hi, I'm the guy so introverted I chose talk to a camera as a side hobby. Great plan, right? And yes, English isn't my first language. I graduated in 1990 with an electronics degree. Then life happened and the soldering iron took a very long nap. Career-wise, I went from IT to video production to VR specialist, and now I work as an audiovisual technical director. Around 2015, I got back into electronics with Arduinos and the like. Then, during the pandemic, I watched one Ben-Eater video too many. I built a 6502 project, expanded on it a few times, tried my hand at the Z80, and eventually fell for the Motorola 6809's overachieving sibling, the Hitachi 6309. It has the same 8-bit heart, but with bigger 16-bit muscles, with a few 32-bit party tricks. One of the most capable CPUs of the era, basically the nerdy kid who skipped a grade or two. So, here's the mission. Build a retro computer from scratch, fully loaded, with the goal of running the NitrOS-9 operating system. It's still maintained today, mostly in a CoCo world, like the cool cousin who never really left the 80s. To make life easier, I'll stick close to the CoCo 3's memory map. With a little luck and maybe a burnt offering of gold-plated ICs to the retro gods, the OS might just feel at home here. But it'll take some convincing. So we'll give it the royal treatment. Real-time clock, polite chip select, a comfy stack, slippers by the ROM, and plenty of RAM in the pantry. If it boots, we celebrate. If it sulks, we call it research and keep going. A quick note, we will be doing some hardware today, so stay tuned. Before the optimism drains away like DRAM without refresh, let's look at the roadmap. Not a mystery novel, just a path from "that's a neat idea" to the glow of a blinking cursor. Time to break out the blueprint, sketched in flux fumes, fueled by too much coffee, and proofread with just the right amount of insanity. We're building a reproducible 6309 computer in stages. The core, your basic nerve center. Add some memory so code has a home. A console so it can chat with you. Control and timing so interrupts act like adults. A dash of blinking lights so we can see it breathe. Followed by storage so it remembers. If the retro gods smile, we boot NitrOS-9 level 1 to serial. After that, inputs. We're talking keyboard, mouse, joystick. Followed by audio, video, and an MMU with even more RAM. The intent, of course, is to proceed with NitrOS-9 level 2. And if I'm not at the insane asylum by then, we follow up with networking. Last but not least, legacy I/O, such as a floppy for the full 80s experience. Well, that's the overview in a nutshell. Clear enough?
Nah, no, not really.
Whoa, where'd you come from?
Dude, didn't you get the memo? I'm using the new Anticipation Video plugin. It allows users to pre-comment on videos as creators are editing them. Get with the times, boomer.
Boomer? Hey, first off, I'm Gen X, and wait, that's impossible. I mean, first off, what's this editing thing you're talking about? And more importantly, that would imply I'm currently facing a potential fourth wall paradox, and your presence could threaten my very existence. That's disturbing.
Yeah, get over it. Listen, I'm not here to cater to your existential insecurities. I just came to comment. Geez, Louise, sensitive much?
That's a lot to take in. Give me a minute, will you? Anyway, thanks for listening to me. I didn't want to take so many hours just to... Wow, that was selfish of me, you know? But I could tell you're a good listener. You practically didn't even blink this whole time. You're a good friend, Jack.
John. My name's John. Besides, it only felt like mere seconds.
Seconds. So, what were you here for in the first place anyway? I forgot after all this time.
Listen, as I was trying to say like a minute ago, that wasn't a roadmap, it's more like a table of contents.
You're funny, Jack. After all we've been through, you're such a kidder. A minute ago. You crack me up.
John. My name's John.
Want more details, you say? Fair enough.
Finally.
Okay, great. As per Jack's request, let's slow roll each stop so nobody gets lost more than we are now. We start slowly by laying down the power rails, a supervised reset, and a stable clock. The 6309 sits behind bus buffers, so it isn't arm wrestling every peripheral. Programmable logic devices handle various housekeeping tasks, such as address decode, wait states, and other nifty things. And yes, I'll swap for some faster oscillators in an attempt to push the hardware to its limits.
Sorry to interrupt, but you do realize you're practically giving a step-by-step plan here, are you? A roadmap is supposed to be like more high level.
Oh, sorry, Jack. You're right. Let me consult with my writers a bit. Reset lands us in ROM. We shadow copy into RAM, then run from RAM for speed and reliability. The memory controller equations in the PLD keeps the ROM out of the way under lock and key until the next reset. We bring up serial communication with a USB to serial converter. Optionally, we could set up a second serial port with an RS-232 transceiver to talk to peripherals, but that can be done anytime down the road. We add a system tick, then a real-time clock with non-volatile RAM, and maskable priority interrupt controllers for IRQ and FIRQ. That gives us a heartbeat, time of day, and interrupts that don't panic when two things happen at once. I suggest power-on self-test codes on 7-segment displays, along with a few other control signal LEDs. Also, doubles as holiday decor because I love lighting things up like a Christmas tree. A computer without storage is rather pointless, and compact flash is probably the easiest to interface to. No bit-banging mumbo-jumbo. For NitrOS-9, we'll use an OS9 file system image, if one exists other than in my imagination. Right away, NitrOS-9 Level 1 boots from compact flash, displaying the prompt on the console on the first try. Yeah, easier said than done. There's some homework to do on this one, for sure. Looking under the hood of NitrOS-9 is probably the easiest way to guide me into writing proper drivers. If the OS argues back, that's a feature. Matrix keyboard for typing, mouse for pointing at things, and 2 joysticks because games are a system test with better marketing. Which reminds me, I'll have to take into consideration that my joysticks insist that up and down are just suggestions. Programmable sound generators. We love them. My goal is to have as many channels as possible, without overtaking board space. I want stereo, and if I can get panning too, that would be awesome. A nice to have would be MIDI, but I'm not sure it's in the Retro Gods plans for me just yet. But maybe one day. I want video via a display processor. One thing's for sure, no shared RAM that steals half the CPU's cycles. The video subsystem gets its own VRAM, so the CPU doesn't idle. And the CPU can't do all the heavy lifting either. In comes a display processor to offload a good chunk of the work, amongst other things, provide sprites and scrolling. At a minimum, we should have RGB or component video, and in an ideal world, VGA. I need 2 megabytes of RAM. I can never tell them apart when I have retro computing envy. Since we're slightly over the addressing limit, we have to add page block mapping CoCo style. That's 8 times 8K logical pages in the 64K CPU view, each mapped to physical blocks so the OS can stretch out. Think library card swap. Same 64K reading room, we just wheel in a different shelf. We boot level 2 and run some apps. If it sounds simple, it won't be. The simple part has expired. It's pushing daisies by the roots. This time around, I fear it will consume me to the grave. The video driver alone will cause me migraines, if not madness. But, thankfully, level 2 is not all fun and graphic games. There is a text mode component to it. If I can just get that to work and optimize all my drivers in that mode, then I'll be able to ease into working my way up. And if it sings and scrolls, we tag the build and resist feature creep. Meh, for 5 minutes. We start with a TCP/IP offload controller, then we build your basic run-of-the-mill networking stack. Once the basic works, we could try Wi-Fi bridge. Crossing over would be easy at this point, right? For the full retro ritual, we could or should have a floppy and hard disk drive. Reads, writes, check. Step index ready behaving? Check. Recover after faceplants? Also check. With the OS writing shotgun. But I'll start delving into that right after inventing anti-gravity. Sounds more manageable, but I promise I'll give it a shot. We all love the smell of vintage silicon in the morning, but let's be honest. The good chips are rapidly disappearing, and the fakes are breeding like gremlins after midnight. There's a day coming when original VDP means very dubious part. So yeah, plan for the best. Prepare for the FPGA or microcontroller. Which begs the question, how do we swap our beloved dynos without losing the retro soul? Let's talk about options. When we think of solid modern alternatives, we usually tend to think of FPGAs, and rightly so. But those require a very particular set of skills. Skills acquired over a very long career. Skills that make FPGA engineers a nightmare for the hobbyists like you and me. They will find you, and they will teach you Verilog. And what we often overlook is the microcontroller. And right now, one probably just popped into your head. If your first thought was the Pi Pico, congratulations! You've unlocked the secret bonus round. And honestly, a solid choice. It's versatile, dual core at 150 MHz, dirt cheap. And yes, plenty of people already use it as a helper chip in vintage computing projects in some form or another. Me? I've set my sights on another, the Parallax Propeller 2. It's pricier, sure, but it delivers 8 cores at 300 MHz, tons of I/O, and it can crank out video signals from composite to VGA to DVI, plus audio. The catch? It's a 100-pin surface mount package, definitely not as manageable as the Pico, which can be adapted for breadboard use, or surface mounted with its castellated edges. I'm sure the future will bring us sleeker and beefier microcontrollers with even more features. The magic rule: the CPU should still think it's 1995. The helper's job is just to keep the lights on, not sneak in a modern brain transplant. In any event, whichever choice you make, I still think writing assembly language for a microcontroller is always more approachable than programming FPGAs, at least at the hobby level. Don't get me wrong, I'm not ruling out FPGAs, I just know they're in a whole different league, for me at least. Still, maybe there's an FPGA for dummies out there, with my name on it. Replacing old tech with something more contemporary should not be considered as cheating, but rather an opportunity to develop something like, what if Tandy released a CoCo 4? Video. Choosing a helper microcontroller that can natively generate video signals is a smart decision. Imagine you could not only dedicate a single core to a video, but many. Imagine the quality of that video without impacting the CPU in the least. Well, unless you go overboard with GPU-like features. But I'm sure there's a sweet spot somewhere. Audio. Real PSGs will eventually dwindle out. It's an it's a fact. On the other hand, with the proper microcontroller, you could dedicate a single core to a 16-bit mixer using integrated stereo DACs, providing 24 channels at 44 kHz sample rate, with an even better signal-to-noise ratio to boot. All this with enough headroom to spare in the core. Inputs. To be honest, I'm going full microcontroller right away on this. The chip count reduction and board space savings is massive. Consider this. You need a 40-pin PIA for the undebounced matrix keyboard, a 40-pin PS2 controller with accompanying glue logic for the mouse, and a forest of other smaller chips for the joysticks, regardless if they're analog or digital. Depending on the microcontroller, you could fit everything into a single one. Even better, dedicating one core to inputs integrated into the same MCU the video and audio helpers reside. Storage. You can't buy CF cards as easily as before, but you can still find them. However, if and when they go the way of the dodo, we'll just switch to your standard run-of-the-mill trusty SD card. Floppy and hard drives. I guess we could go SATA to replace parallel ID drives. Should be easy enough with the right adapter. However, if you've been living under a rock for the last 20 to 30 years, you know that floppies are an issue. You can be lucky and find new old stock, but used is the new. But you knew that, right? I did see some on AliExpress, but that seems dubious. Then you have eBay, filled with many past, present, and obvious future regrets. But if you're patient, maybe Marketplace will send you a birthday gift. My point is, alas, there's no replacing floppies with modern counterparts. We want them because of how they make us feel. Retro takes us straight back to our younger selves, carefree, blissfully unaware of adulthood, and completely wrapped in amazement and wanderlust. That is nostalgia. I know, there's a lot to cover in this series, and we haven't even touched software yet. I mean, I could open Pandora's box and ask, what if the CPU was just a soft core inside an MCU? We may have to consider this one day. As I've been sketching out preliminary schematics in KiCad, Don't worry, I'll walk you through them as we go along. I kept asking myself, is this feature creep or essential? I'm genuinely curious about what you think, so drop a comment down below. You're probably already saying or shouting, but what about this? What about that? Hopefully inside your head, not in public. Either way, let me know, because this YouTube thing still doesn't transmit thoughts, so not yet anyway. Whoa, just in case. Ew, whoa, what's that? I can hear thoughts. Everybody. A million voices chanting one sacred question. What? That's it? What would Periphractic say? Really? That's not the meaning of life or something existential like that. Come on, it's obvious. Look, we all know what PCB stands for. It stands for Please Check Batteries. It's step 0 in debugging. Right? And now, a word from our sponsor, PCB Way. Quick reality check. Even the nerdiest retro projects still need proper boards. That's where PCB Way proves its worth. With prototypes starting at just $5, it's really hard to go wrong. Here's my custom matrix keyboard PCB. Clean traces, sharp silkscreen, and it almost makes me look like I can type with purpose. With a matching metal plate, laser cut, etched, and flatter than my learning curve on day 1. And look at this, they align perfectly. And this little project, my ATF 1508 PLD to breadboard adapter, every hole exactly where I asked for, instead of where fate usually puts them. PCB Way isn't just PCBs either. Assembly, because sometimes tweezers just won't cut it. Take advantage of their expertly tuned pick-and-place machines for your next project. 3D printing. From odd brackets to custom parts, they'll make shapes you didn't think possible. That sounds like something I need. CNC machining. For the shiny precision bits. I always dreamed of owning a CNC machine. With PCB Way, there's no need anymore. Sheet metal. Perfect keyboard plates, sturdy enclosures, panels cut and etched to spec. Sounds too good to be true? But wait, there's more. Injection molding, when only polished product-ready plastic parts will do. Is that cool or what? From start to finish, it's professional, reliable, and fast, showing up in ESD foam folded better than my origami of excuses. Without PCB Way, I'd probably still be hunched over a kitchen sink, pretending I'm MacGyver attempting to etch a PCB. Trust me, no one wants to see that episode. Link in the description. A quick word on the software side. Things could slow down once I dive into assembly-coded drivers. I'll cover every subroutine, naturally. But honestly, what you're seeing on screen right now, well, writing software for these feels like writing a novel blindfolded while a cat walks across a keyboard. Abstracting the hardware layer into working drivers will be somewhat tricky. I'd love to go bullet by bullet here, but the truth is, I don't even know where to start this early on in the project. Don't worry, I'll figure it out. I always do. I may play dumb on YouTube, but it's just an act. Most of the time. A lot of what lies ahead lives way outside my comfort zone. File systems, floppy and IDE timing, baby network stacks, and rolling my own video and audio helper drivers. I know the map the way you know the Encyclopedia Britannica because you skimmed a table of content once. That's why the more difficult bits are parked later in the roadmap. By then, I'll have more tools, acquired the necessary knowledge, and gained the wisdom to finally know not to put tomatoes in fruit salad. I'm patient and, let's say, usefully stubborn. Once I bite into a bone, I don't let go. Think friendly pitbull. So expect some U-turns, self-roastings, and the occasional confetti moments when it finally clicks. I brought the snacks and extra flux. Alright, courage topped up. Ah yes, the classic knob test. You do it once, swear you'll never do it again, and then end up doing it for every CPU you own. Guilty. Let me highlight each section to illustrate with this one. First, we have the reset circuit. It's a simple momentary switch connected to a reset IC. Besides it is the 555-based variable clock. A 555 in astable mode is basically a square wave factory. Captain Obvious over here is the nerd-in-chief of all 8-bit CPUs, the HD63 CO9P. The data bus is tied to hex 12, which is the no operation instruction. That will in turn drive these bar graph LEDs. When powered up, you'll see the LEDs count in binary over and over again. We start with a fresh breadboard, then add a reset button, one end tied to ground. Place the DS1813 reset IC to the other side of the switch. Connect VCC and ground to the power rails. Now drop in a 555 timer chip. Hook up VCC and ground to the 555. Insert a decoupling capacitor because noise gremlins are real. Connect pin 2 the trigger to pin 6 the threshold. Tie pin 4 reset to VCC. Place a 100K potentiometer to control clock speed. Add a small capacitor on pin 5, which is the control voltage to keep timing stable. Wire a 1 kΩ resistor from pin 7, which is a discharge pin. Connect pin 7 to one end of the potentiometer. Wire a 200 ohm resistor to pin 6. Add a 0.1 microfarad capacitor from pins 2 and 6 to ground. Insert a 200 ohm resistor plus a green LED on the output. Plug in the power connector so we can test things as we go. For fun, stick an LED on the reset line. Uh-oh, reset is staying high for too long. Ah, that tiny switch hates breadboards. I'll swap for another one. Ah, much better. About that reset state. Oh, classic mistake. Reset IC was flipped around. Fixed it. I spotted another wiring slip though. Let's reconnect the pot correctly. While we're at it, let's put the clock output on an LED too. Turn the pot, watch the blink rate change. Reset works, yay! Now it's CPU time. Feed the clock to pin 38. Pull up halt on pin 40 so the CPU won't nap forever. Pull up mReady pin 36 to avoid white states. Pull up bus rec pin 33 so the CPU rules at bus. Ground pin 1, which is VSS. Pull up NMI, IRQ, and FIRQ. Power the CPU at pin 7, which is VCC. Tie the data bus to hex 12. That would be pin 24, D7 to low. Pin 25, D6 to low. Pin 26, D5 to low. And pin 27, D4, which is high. Pin 28, D3 low. Pin 29, D2 low. Pin 30, D1 will be high. Pin 31, D0 will be low. Wire A15 for an upcoming bar graph LED. I've got some 8-segment ones, looks pretty slick. Install the second bar graph for the lower address lines. Wire A14 and A13. Don't forget the 330 ohm SIP resistor packs for the current limiting. Tie the common pins of the resistor packs to ground. Now connect a 12 down to a 0, and that would be pins 20 to pin 8. Hook the reset circuit to the CPU reset pin 37. And now it's time to power on. And nothing. Miswired again. Oh, reset and clock are shorted. Oops. Still dead. Reset jumper was misplaced. Reconnect. Power up. And reset. Now we're cooking. Crank up the pot. Faster blinks. It works. I'm happy. If it's dead or jitters randomly, odds are you miswired something, or that bargain bin CPU wasn't the bargain you thought. If your CPU is truly lifeless, well, build a mini casket and add a plaque saying, "Here lies the 6309, the best of them all." Alternatively, you could simulate all this using an Arduino Mega, like this one, if you want to have mega fun. I've done it before. It works. It just takes longer for the same result. You probably noticed I was a little vague about specific parts, and on purpose. As the project evolves, I may GPS the plan, recalculating. I might swap parts, change how something's implemented, or even shuffle the order I presented the roadmap in. New ideas will happen, so will the occasional "oops, I shouldn't have done that." The biggest reason for keeping it loose is you, the hive mind. Yes, including you, Mike from Edinburgh. Together, we come up with smarter approaches, and I want to leave room for your feedback. I read it, I consider it, and I'll act on it, especially if it lands before I order 5 PCBs and a bag of regrets. Think of this as early access roadmap, patch note to follow. Next up, we'll bring up the CPU, clock, and buffers. If time is on our side, we'll give our first PLD a shot. And remember that Mega? Well, we'll convert it into a logic analyzer to test everything. Get ready for some benchcam heavy footage with real builds and code on screen. Don't forget to like, subscribe, ring that notification bell, and politely remind your soldering iron who's the boss. Retro gods, please accept these gold-plated CPU sockets as tribute. See you in the next episode. I can read it offline, no problem, but when I read it on a prompter, geez, nightmare. And welcome to the episode. And eventually fell for Motorola's 6809s over the NitrOS-9 operating the cool cousin who never really let no. Before the optimism I said it again. Optimism. With just the right amount of insanity. The glow of a blinking cursor. Console, so it can no, let's try it again. Then run from RAM for steep speed and keeps the ROM, not the rum, the ROM. No bit banging, bump. Need to make it like so. If it sounds simples? Why, yeah, it's simples. I've got pimples with simples. It's set piece. Right after inventing again. Skills acquired over. Not to sneak in a new brain. not to sneak in a modern brain transplant. It's a fact. I think I should leave it, but that sounds dubious. But that could be dubious. As I've been sketching out preliminaries, I'm genuinely. That's way PCBware. Yeah. Whoa! You finally know not. If it's dead or jitters randomly, odds, you could simulate all of this using an Arduino. Fudge, will that? You could simulate all this using an Arduino Mega. Lao? No, it's now! Will I ever finish it?
Didn't you get the memo? I'm using the anticipation. Didn't you get the memo? I'm using the new anti-new.
It's a piece of mud cake made with 100% organically grown mud.